This is Geometry, Unit 8, Day 3 homework. This is for page 749, section 11.4. So we're looking at number 11. We're supposed to find the length of arc AB. So that's the distance for the arc AB. We're going to write a proportion. Arc AB over 2 pi r is going to equal that central angle over 360. So we don't know what the arc is. 2 pi r is 2 pi times 6. The radius is 6 meters. The central angle is 40 degrees. So we want to get the AB by itself, so we're going to cross multiply. So AB, arc AB, is going to equal 12 pi times 40 divided by 360. We'll take our calculator. The numerator is 12 times pi times 40. We're going to divide that by 360. So the arc itself is 4.19. And the units are meters. For number 12, we see the central angle is 120 and the radius is 14. So this arc AB over 2 pi times 14 is going to equal 120 over 360. We'll cross multiply and get arc AB equal to 28 pi times 120 divided by 360. And using our calculator, use parentheses, so 28 times pi times 120 divided by 360 is 2932. For number 13, here we're looking at centers P and we're looking for the length of arc AB. We know that the central angle is 45. I don't know what the radius is. I have the diameter as 8. So if D equals 8 feet, then the radius is going to equal 4 feet. So now the arc of AB over 2 pi r. I could have used 8, I imagine. Pi times d is another way to calculate circumference. We'll use that here in a second. We didn't have to break it apart. So we'll cross multiply. AB, arc AB, is 8 pi times 45 all over 360. So use parentheses for the numerator. 8 times pi times 45 divided by 360. 3.14, that's actually the number of pi. 3.141592654. So 8 times 45 must be 360, and that would cross out and leave you with pi. Just the way it worked out. For our next questions with number 15, we have our figure drawn. Angle QPR is supposed to be congruent with angle RPS. When your central angles are congruent, then you know your intercepted arcs are also congruent. We're supposed to find the measurement of QRS. What is the measurement of arc QRS? Well, QRS is the whole thing, not counting the 60. Central angle equals the intercepted arc. So we're going to say 360 minus the 60. That tells us that we're at 300 degrees. For number 16, we're supposed to find the length of QRS. So to find the length, we're going to use our formula. Arc QRS divided by 2 pi r, the radius is 8. The angle we calculated to be 300 over 360. We want QRS by itself, so we're going to cross multiply. So we have 16 pi times 300 divided by 360. Using our calculator, parentheses for the numerator, 16 times pi times 300 divided by 360, we get 4189. And that's the length, so that would be feet. Number 17, we're supposed to look for the measure, so that's a degree value, of arc QR. Well, if both arcs are the same, then I know each arc is going to be half of our 300. So the measurement of QR, arc QR, is going to be 300 divided by 2, which is 150 degrees. So number 18, to find the measurement of Rsq, is the whole circle, not counting that arc RQ. We're looking for the measure of arc Rsq, and that's going to be the whole circle, not counting the measure of arc QR. So that's going to equal 210. Now we're supposed to find the length of arc QR. So QR over 2 pi r is going to equal that angle, which is 210, over 360. So that's one way we could do it. But I think we also already figured out what QRS was. We could just divide that value by 2. That should equal the same thing. Let's see how that works out. Oh, I'm sorry, I just used 210. But we're supposed to find the length of QR. QR was just 150. So we'll cross multiply. So arc QR is 16 pi times 150 divided by 360. Using our calculator, I'm suspecting that the answer is going to be 20.94. But let's take our parentheses, 16 times pi times 150, and divide that by 360, and we get that 20.94. That was half of our 41.89. Number 20, we're looking for the length of Rsq. This is the length of arc Rsq. So we found the length of QRS. We found the length here. We haven't found the length of QS yet. So we could take the whole circumference minus the part we just found would give us Rsq. That's one way we could do it. You could also say that Rsq over 2 pi times 8 equals our angle. I'm doing Rsq, which we found out was 210, over 360. Cross multiply. So arc Rsq is going to equal 16 pi times 210 over 360. So using our calculator, 16 times pi times 210, that's the numerator. You don't really need parentheses for a lot of these because order of operations would multiply straight through, but it just keeps things safe. 360, which is 29.32. And this would be in feet. Okay, let me see what numbers we're doing next. 26, 27, and 28. For number 26, we have an equation of a circle. We know from our past that the center of the circle is at the origin and the radius squared. R squared equals 16. So R is going to equal 4. For us to find the circumference, which is 2 pi r, we know that the circumference is 2 pi times 4. So in terms of pi, we don't need a decimal, is going to be 8 pi. With number 27, we have the r squared equals 9, so r equals 3, circumference equals 2 pi r, so circumference equals 2 pi times 3, so we're going to get 6 pi. Okay, true, in this case the center is not at the origin, but that doesn't have anything to do with the circumference. The circumference has completely everything to do with the radius. Our last one, x squared plus y squared equals 18. Well, we know that r squared equals 18, so when you take the square root of 18, we're we're going to get 9 times 2. 9 times 2 can be reduced down to 3 root 2. And then we can plug that into our circumference formula. So 2 times pi times 3 root 2. That gives us 6 pi root 2. Sometimes you'll see it written as 6 root 2 pi. It's not that the pi is inside the radical, but it's your number followed by pi.